Now let's look at when we're given a number in scientific notation and we want to go back to standard form. So first, we're going to follow a different set of 4 steps. We're going to first write the coefficient, so in that case, it would be 3.5. We're then going to add a number of zeros equal to the exponent, to the right for positive exponents and to the left for negative. In our case, we have a positive 4 as the exponent, which is why they drew to the right 4 zeros. We're then going to move the decimal the number of places indicated by the exponent, again to the right for positive exponents and to the left for negative. So they move this decimal to the right 1, 2, 3, 4 spaces to the right because it's positive to end up here. And then they don't need the unnecessary 0 that's left over. And if they add in a comma, that gives us 3.5 times 10 to the 4th is 35,000 in standard form. Now let's look at a couple of examples where we have to fill in the steps ourselves. So here we want to express 1.02 times 10 to the 6th in standard form. So the first thing we're going to do is write the coefficient, which here is 1.02. We're then going to add a number of zeros equal to the exponent. Our exponent is a positive 6, so we're going to go to the right for positive exponents. So we'll have 1.02 and 6 zeros to the right. I'm then going to move the decimal places indicated by that exponent again to the right because it's positive. So we're going to move it 6 places to the right. 1, 2, 3, 4, 5, 6. So it'll be 1, 0, 2, 0, 0, 0, 0, 0.00. Now, with numbers in the standard form, these 2 zeros are unnecessary, and we want to add a comma every 3 numbers, so we would have, or 3 digits, so we would have 0, 0, 0, 0, 2, 0, 1, making the standard form of 1.02 times 10 to the 6th 1,020,000. Let's now express 3.42 times 10 to the negative 3 in standard form. Let's look at an example that has a negative exponent. So here we're still going to use the same steps where we write the coefficient. And now we're going to add a number of zeros equal to the exponent, and our exponent is negative, so we're going to move to the left and add 3 zeros to the left of the 3 in 3.42. We're now going to move the decimal that many spaces again to the left because it's negative. So 1, 2, 3. So the new decimal will be 0.00342, the new placement of the decimal point. Now here we don't have any unnecessary zeros. We like to keep that 0 to the left of our decimal. And we don't need commas with decimals, so the standard form of 3.42 times 10 to the negative 3 would be 0.00342. Another example, let's express again with a negative exponent, 2.95 times 10 to the negative 4. Let's write our coefficient, 2.95. We're going to add a number of zeros equal to the exponent. We're going to go to the left because it's negative. So we'll have 4 zeros to the left of the 2 with that same decimal between the 2 and the 9. We're then going to move the decimal 4 to the left because, again, it's negative. So we'll move it 1, 2, 3, 4. So that would give us 0.000295. Again, we like to keep the 0 to the left of the decimal, and we don't need any commas, so our final answer of 2.95 times 10 to the negative 4 is 0.000295. We can use the calculator to help us with scientific notation as well. When entering numbers into a calculator that are in scientific notation, you can use the EE button, both capital. It means times 10 to the power of. So this button eliminates the times 10 of a number in scientific notation. It's right here located in the calculator, usually next to your parentheses above your number keys. So for example, 9 times 10 to the 8th is entered into the calculator using the 9 button, the EE button, and the 8 button, and shows up at the top as 9E8. We have to think that calculators can help when making calculations in scientific notation, but we want to know when it's most helpful to use the calculators and think of the limitations it may have. We're going to look at a couple examples here of how to enter them into the calculator. So use the EE button to determine its value of these numbers in standard form. So here you would want to enter 4 times 10 to the second would be 4 EE and 2, which would equal on your screen should be 400. For B, 5.7 times 10 to the negative 3, you would want to enter as 5.7 EE negative 3, which should show up on your screen as 0.0057. For C, 9.87 times 10 to the 4th, you want your coefficient 9.87. Then the EE button. And 4 as your exponent, which should read on your calculator 98,700. And finally, D, you want to include your coefficient 1.43. Use your EE button and your exponent of negative 1, which should read on your calculator on your screen as 0.143. When reading a calculator that has a number in scientific notation already, again, we have to remember that the E on the screen, for example here, this E, stands for times 10 to the power of. So which number written in standard form represents the number in the calculator to the right? So first, it's best to note what it would be in our scientific notation. You would have your coefficient of 3.2. The E would represent times 10 to the power of, and here the 9 is that exponent. So 3.2 times 10 to the 9th is going to be 3,200,000,000 and include 7 zeros after the 3 and the 2. Again, we can look at our calculator and have to remember that the E is still times 10 to the power of even if the exponent is negative. So which number written in standard form represents the number in the calculator below? Again, scientific notation, it would be 4.21 times 10 to the negative 11 power. So that's a really, really small number. It would be 0.10 zeros. And 4, 2, 1. So again, it's much easier to read on the calculator with the E instead of having 10 zeros. It might not even fit all the way on your screen.